All right, so here are the Physics 12 Chapter 1 homework problems, and I will solve each of the questions from the homework step by step, and this way you can check your work. All right, so let's get started here. Question number 1. Which of the following contains vector quantities only? All right, so vector quantities have both magnitude, and we're also looking for quantities that have direction as well. So vectors have both magnitude and direction. All right, so if we look at option A, mass is actually a scalar, and speed is also a scalar. So A is actually wrong. For B, we have energy. Energy is a scalar, but velocity is a vector. And for option D, we have displacement, which is a vector, but energy is a scalar, so C does not work. And finally, for D, displacement is a vector, and velocity is also a vector. So option D has option D has two vectors. So D would be the right answer there. All right, question number 2. Which of the following is not a vector? So not a vector, that's the same thing as finding a scalar. All right, and a scalar has a magnitude only. All right, so mass by definition is a scalar. Impulse is a vector, velocity is a vector, and momentum is also a vector. So vectors have magnitude and direction. So for question number 2, the answer would be A. All right, so question number 3. Which of the following statements concerning vector and scalar quantities is incorrect? Incorrect. So we're looking for a wrong answer. All scalar quantities have direction. So that is actually false. Scalars have magnitude only. All vector quantities have direction. That is true. All scalar quantities have magnitude. Yes, that is true. All vector quantities have magnitude. That is also true. So option A is the correct answer. Option A is false. All right, moving on to question number 4. An aircraft is flying due west. So west is in this direction right there. Sometime later is flying due north. So due north. Which vector represents the aircraft's change in velocity? All right, so this question is asking for a change in velocity. So change in velocity, delta V, that's the same thing as your final speed minus your initial speed. All right, so we need to find a diagram that represents a change in velocity. All right, so if we're going due west is going in the left direction. And sometimes it's flying due north. So due north, that's actually going in the up direction. And so this is actually your initial speed. And this would be your final speed. All right, so I want to find a change in velocity. So change in velocity is your final minus your initial. All right, so basically in order to do this question, basically I need to add my VF vector, which is right here. And then I must, this is the same thing as final velocity plus you're adding your negative initial vector. All right, so if I'm flying due west, that means negative V naught would actually mean the opposite of west, so that means I'm flying east. So I'm going to add that to my final vector. So this is my vector in the opposite direction, and if I add those two vectors together, I get a resultant vector going in the northeast direction. So the correct answer here would probably be A. This is considered your change in velocity. All right, so change in velocity is simply your final vector minus your initial vector. All right, so for this question, all we have to do is we take our initial vector there, which is going due west, and we need to change that to the opposite, which would be going in the eastern direction. All right, so that's question number 4. Let's go on with question number 5 now. An airplane which was flying eastward. All right, so eastward is going in this direction. And since that's the first piece of information that the question is giving us, we'll assume that's going to be your starting vector. And later it's flying. So later it's flying in the southward direction at the same speed. So in the southern direction, we are going down. And since that's some time later, we'll call that our final vector. Which vector shows the airplane's change in velocity? All right, so once again, change in velocity is simply your final velocity minus your beginning velocity. Now, this final velocity is the same thing as this guy right there. So I'm just going to add that to that. The problem once again is I need to add that to a negative V naught. And right now I have a positive V naught going the eastward direction. So if I want to put a minus sign there, if I want to put a minus sign right here, that would mean my vector would change in the opposite direction. So it'd be going westward. So negative V naught is actually going westward. So this is your final velocity. This is your negative V naught. And that means if you add those two vectors together, this would be your change in velocity, which is delta V. So delta V is going in the southwest direction, and that would be option number D. All right, let's move on to question number 6 now. Two velocity vectors V1 and V2 are shown. So here's V1, and here's V2. Which of the following best represents the resultant? Okay, so basically, resultant just means we're just adding the two vectors, V1 plus V2. So if I add V1 plus V2, here would be I'm going to redraw this again. This is my V1. And if I add that to V2, you simply go head to tail. All right, so basically this is like your tail, this is your head, this is your tail, that's your head. So you're simply adding head to tail, and your resultant vector would simply be this vector right there. So that's here's my tail, and that's my head. All right, so there's my resultant vector, and as you can see, that matches option number C. So C would be the right answer there. All right, question number 7. Which of the following vector diagrams shows A as the sum of B and C? So we're looking for a diagram that represents A equals to B plus C. All right, so let's go through all of these diagrams here. For option number A, I have my A vector being added to my B vector. So option A is actually my A vector plus my B vector gives me my resultant vector, which is my C vector, which is not what we're looking for. So option A would be wrong. Once again, here's my tail, there's my head, there's my tail, there's my head, and this is my resultant vector. We're adding head to tail. All right, for option number B, I can see that my B vector is being added to my C vector, and my resultant is actually my A vector. So if I had to write this using sum notation, this would simply be my B vector plus my C vector, giving me my resultant, which would be my A vector. So that actually does match what I'm looking for, so B would be the right answer. For extra practice, let's just go over options C and D. Basically for C, I can see that my B vector is being added to my A vector, and that gives me my resultant of my C vector. So if I wrote this as a summation, this would be vector B plus vector A gives you vector C. And finally, the last one here, I can see that vector B is being added to vector A, which gives me my resultant